Hello everybody, this is lesson 16 of the lecture Macroeconomics. I will discuss the slides 1 to 36 of chapter 4, the Keynesian model. Before we start, let me give you an overview of this chapter. In this chapter we will discuss the Keynesian textbook model of a macroeconomy. In the first section, I will talk about the historical background of the Keynesian theory and the major difference between the Keynesian and neoclassical model, the assumption of constant prices for goods in the short run. We will then derive a graphical version of the Keynesian textbook model in the same way we did this for the neoclassical model. We will use this model to analyze the same type of shocks and policy measures in section 4.2 and 4.3 as we did under the assumptions of the neoclassical model. As we will see, the Keynesian economy is much more unstable than the neoclassical economy. But fiscal and monetary policy can influence now the real level of GDP in the short run, and thus can be used to stabilize the economy. After this analysis, we will turn to the long-run version of the Keynesian model in section 4.4. In the long-run version of the Keynesian model, the assumption of constant prices for goods is replaced by the assumption that prices are flexible. As we will see, under the assumptions of flexible prices, the Keynesian model provides nearly the same results as the neoclassical model. We will then draw some policy conclusions from the Keynesian model in section 4.5 and analyze the empirically practiced fiscal policy of German governments. So let's start with a look on the historical background of the Keynesian theory. Until the world economic crisis of the years 1929 to 1939, the neoclassical model was a kind of consensus model of market-oriented economists. This evaluation of the neoclassical theory was significantly altered by the world economic crisis. Such a sharp and lasting break of the economic development was inconsistent with the neoclassical hypothesis of the immanent stability of market economies. Rising unemployment, bankrupt companies, and decreasing household incomes caused social problems that called for new solutions. The trigger of the crisis was the collapse of the New York Stock Exchange at October 24 in the year 1929. Cause of the stock market collapse was an overvaluation of stocks, what we call today a speculative bubble, in the course of the so-called Roaring Twenties, which was driven by upcoming new technologies similar to the new economic crash or dot-com crash at the start of the year 2000. Surprising and new was, however, not the stock market collapse, but its long and lasting effect on the real economy. This diagram shows the development of the Dow Jones Index. Dow Jones Index is very often used index for the performance of the New York Stock Exchange before and after the stock market crash of the year 1929. The Dow Jones Index is based on the average market value of the 30 largest American enterprises traded on the New York Stock Exchange. The Dow Jones shows that during the so-called Roaring Twenties, this period of time here, the stock market experienced a long-run boom. Dow Jones Index was growing over a long span of time, nearly a decade. In the beginning, new technologies came up, especially the connection of private households to the public electric power grid created demand for new goods like electrical kitchenware, refrigerators, or vacuum cleaners, just to give a couple of examples. The first public radio stations opened also in the 20s and created, for example, demand for radios and so on. In the beginning, the increase of stock market prices was justified by increases in corporate profits. But in the second half of the 20s, stock market prices moved more and more away from the profits per stock, mostly driven by cheap money credits made possible by expansionary monetary policy of the American Central Bank, the Federal Reserve. In summer 29, the American economy started to cool down, which was a result of a more restrictive monetary policy by the Fed, which had caused an increase of interest rates over the years 1927 to 1929. So the stock market became more and more nervous, and in the course of the summer and finally started to crash on Thursday, the 24th of October. By an intervention of 4 large commercial banks, which bought large volumes of stock, prices, however, recovered the following Friday. But the following Monday, selling began, and on Tuesday, a real panic started. The Dow Jones lost 13% on Monday and 12% on Tuesday. Stock prices fell from their maximum at 381 to a level of 198 in a couple of days. Interestingly, until April 1930, prices recovered up to a level of 300 nearly. However, the deterioration of the real economy, the recession that took place in the real economy, caused then a steady slide of stock market prices until the summer of the year 1932, when the Dow Jones Index reached the bottom with 41 index points only. So these shaded areas here indicate recessions, and this recession was a very strong recession. The stock market crash caused a deep loss of net wealth, not only for rich households, but also for medium and small income households, which became invested in the stock market during the long boom in the 20th before. As a result of this loss of net wealth, households reduced their consumption demand in order to create additional savings to rebuild their net wealth. This reduction in consumption demand triggered one of the worst recessions experienced in modern history. Today, this period is called the Great Depression. In the course of this recession, it became clear that the predictions of the neoclassical model with regard to the harmlessness of demand-side shocks was wrong. A closer look on the numbers in this table shows this. First, the numbers clearly show how strong the recession was. Over a time period of 4 years, the unemployment rate was rising. In the year 1933, the unemployment rate reached a maximum level of 25% of all American workers. Second, real GDP was falling with two-digit rates over a period of nearly 3 years. All domestic expenditure components of GDP, household consumption, investment demand, and government consumption were falling. A closer look at consumption and investment demand shows that the prediction of the neoclassical model did not work. The neoclassical model predicts that a reduction of household consumption should lead to an increase in savings, which should then reduce the interest rate such that demand for investment goods should grow and replace the reduction in consumption, such that total demand stays constant. However, this mechanism did not work in the world economic crisis. So this was a new situation that could not be explained by neoclassical theory. Other countries, like Germany, made quite similar experiences. Under these historical circumstances, the English economist John Maynard Keynes developed his new macroeconomic theory, which was intended to explain the consequences of the world economic crisis and to deliver economic policy recommendations appropriate to overcome such a crisis. This theory was published in a book with the title General Theory of Employment, Interest and Money. In this book, Keynes contested two basic assumptions of the neoclassical theory by assuming that, first, in the short run, prices for goods and services are fixed, so that they cannot decrease in case of a reduction of goods demand. As a consequence, he assumed that instead of goods prices, the supply of goods adjusts to changes in demand. This is what we call today Keynesian price rigidity. Second, Keynes made the assumption that household consumption is only a positive function of household income. So if household income goes up, consumption goes up, and if household income goes down, consumption goes down. The negative impact of interest rates on household consumption can be neglected, according to John Maynard Keynes. This type of consumption function is today called Keynesian consumption function. The Keynesian consumption function corresponds at first sight much better to empirical observations than the neoclassical consumption function. The empirical correlation between consumption and household income is indeed much stronger than the empirical correlation between consumption and interest rates, as the following graphs demonstrate. As this diagram shows, there's a strong positive correlation between disposable income of households, measured here on the x-axis in billion euro for Germany as a whole, and household consumption, measured here on the y-axis, also in billion euro. Both time series are calculated in prices of the year 1995, so inflation is eliminated. Running a regression on the relationship between disposable income and consumption of households shows that 89% of disposable income is typically consumed. This means that household income has indeed a very strong impact on household consumption, just as postulated by the Keynesian consumption function. And it is clear, since all points lie very close to this regression line, that the correlation is very strong and significant. The error margin is very small in this regression. As this diagram shows, the correlation between the interest rate measured now on the x-axis and household consumption measured again on the y-axis is much weaker. A linear regression shows that there is indeed a negative correlation between the interest rate and household consumption. However, the deviation of the single observation points from this green line is much larger, which indicates that the correlation is much weaker. So we can indeed find a negative influence of the interest rate on consumption as postulated by the neoclassical consumption function, but the influence is weaker as the positive influence of disposable income on household consumption. We have just seen the diagram before. The second basic difference between Keynesian and neoclassical theory is what we have called Keynesian price rigidity. In neoclassical theory, an increase of production output causes an increase of marginal costs, so that firms increase their prices, and vice versa. Consequently, an increase of the demand for goods above supply causes an increase of the prices of goods and vice versa. In Keynesian theory, firms do not immediately adjust their prices to production costs. An increase of the demand for goods causes a corresponding increase of the supply of goods. The prices of goods stay, however, constant. Now, who is right, Keynes or the neoclassics? Let's have a look at the result of empirical studies. This table displays the result of a large sample of firms in the founding member states of the European Monetary Union undertaken by the European Central Bank. The European Central Bank asked these firms to report their pricing practices. As these firms reported, their adjustment of prices is indeed quite reluctant. For example, German firms reported that only 21% of them adjust their prices more than 4 times a year. Another 21% adjust their prices between 2 and 3 times a year. 14% reported a price adjustment of 1 time per year, while an astonishingly large number of 44% said to adjust prices less often than 1 time per year. The average number of price adjustment was 1 time in a year. For the other countries, the table reveals quite similar numbers. From these and similar studies follows, firms do not immediately adjust their prices to changes in costs. Instead, they keep their prices constant over a longer period of time, just as assumed by Keynes. If firms try to maximize their profits, they should, in principle, change their prices when their costs change. Why then do firms not actually change their prices more often? In reality, changing prices causes costs. That's the most important point of an explanation. For example, there are internal organizational costs, information of staff members, information of distribution chains, of sales agents, and so on. Then there are external communication costs, explication and justification of price changes to clients, which plays a quite important role in some industries. And finally, there are also technical costs like printing costs of price lists or mailing expenses. If the costs per price change are higher than the return of a price change, a continuous adjustment of prices is not profit maximizing, as the following diagrams show. Let's assume that the costs of a price change per year are constant and equal 3 euro. So if we measure the number of price changes along this axis here, and the y-axis measures the costs, which are in this numerical example equal to 3 euro. The shape of the marginal cost curve of price changes should be quite plausible. This shape of the marginal cost curve should be quite plausible. A somewhat increasing marginal cost curve would not change the result of the analysis. So, for example, if a company changes prices only 1 time per year, in this example the costs would be equal to 3 euro. So this area here represents the costs of one price change, the number of price changes times the price of a price change. If a company changes the price of its product 2 times per year, the cost would equal €6. 2 times 3. So then the cost would be equal to the surface of this rectangular area here. The marginal return of a price change should, however, decrease as indicated by this curve, because the return per price change will typically decrease if the number of changes per year grows. For example, the return of 0.5 price changes in a year, this means one price change every 2 years, will normally be quite high, since it is very likely that a significant change in production costs and demand strength will occur within a time span as long as 2 years. To the contrary, the return of, let's say, 4 price changes per year should normally be quite lower, since it is not so likely that significant changes of production costs and demand strength will occur every quarter. If you put the marginal cost curve and the marginal return curve together, the intersection point tells us where the profit maximizing price change per year lies. In this example, it equals 2 changes per year. If we would instead choose only, let's say, 1 price change per year, the return of a price change would be higher than the costs, such that more often price changes would be profitable. If you would instead, for example, choose 4 price changes per year, the return of a price change would now be smaller than the costs, such that less often price changes would then be profitable. So the optimum number of price changes is indeed 2 in this special numerical case. As a result, we find that the profit maximizing number of price changes per year must be 2. Where the marginal costs of a price change are just equal to the marginal return. Now we can use this diagram to analyze what happens if the costs per price change grow, for example, by this amount. As the new intersection point shows, the optimal number of price changes per year falls when the costs per price change grow. In this case, from 2 price changes per year to 1 price change per year. Consequently, the higher costs per price change adjustment, the lower the number of profit maximizing price adjustments per year. This diagram shows it is possible to explain why firms on average do not change their prices more often than 1 time per year, with standard microeconomic profit maximization behavior. An optimal adjustment of prices according to the current demand and supply situation causes an additional return, but this return has to be compared to the additional costs caused by such a price adjustment. Only if the additional return is at least as high as the additional costs, a price adjustment is actually profitable. Depending on the relation between costs and return of a price change, it can be profit maximizing to hold prices on average constant for a time span of a year or even longer. Rigid price setting and profit maximization behavior are in fact compatible. The Keynesian theory assumes therefore that in the short run means within this framework a time span of 1 year, firms keep their prices constant. So the price level P is constant within 1 year. If the demand for goods changes in the short run, firms do simply adjust their production instead of prices to the demand for goods. Consequently, in the short run, firms' production of goods is always equal to the sum of household consumption demand plus firms' demand for investment goods plus government consumption demand. Consequently, in the short run, demand for goods does now determine the supply of goods. This means that in the Keynesian world, under the assumption of fixed prices, Say's theorem does not hold any longer. Now, the demand for goods determines the supply of goods and therefore household income, and not vice versa. This contrarian law to Say's theorem is called Keynes' theorem. So much for this lecture. In the next lecture, we will develop the most important tool of the Keynesian theory, the Keynesian cross.